people building them. A new engine must roll off the production line every 36 hours.
Morning, Kev.
Morning, Johan.
All right, mate.
This week it's my turn, but I tend to be more times in a suit than not.
Wow, actually, I could be building one of these in maybe a few months, or designing one of them. Maybe one day.
There you go. That's it. Look at that beauty. It's a work of art.
Rolls-Royce's main assembly plant is a vast 300-acre complex of factory buildings in the southwest corner. The company's real heritage is aircraft engines. In fact, they've powered some of the world's most iconic aircraft, from Second World War fighter planes and the Harrier jump jet to the much-loved Concorde. And that heritage continues today, powering helicopters, business and military jets, and even ships. But the star product is the pioneering family of Trent jet engines, including the newest Trent 1000 for the Boeing Dreamliner. All the Trent engines are designed for jumbo-style wide-bodied airliners, like Boeing's 777 and the famous Airbus Super Jumbo. But this engine, for the Airbus 330, is the biggest seller of all. In 15 years, the Trent 700 has clocked up 13 million flying hours.
It's a massive machine, but it's a real piece of precision engineering too.
Weighing at least 5 tons, each Trent engine is worth several times its weight in silver. Only 2 companies in the world are capable of building engines this good.
It's a very tough competition between one of the most powerful and competitive companies in the world in General Electric. If you look at all the latest new technology aircraft, all have selected Rolls-Royce engines to power the first flight.
It carries a payload of 242 tons at 37,000 feet for 9,500 miles, which, as you can imagine, is a serious challenge for any technology to deliver. So it really is at the high end of manufacturing and assembly. And I often describe what we do as producing things of beauty.
But the popularity of the Trent 700 is also the factory's biggest challenge. With orders placed to build 400 new engines, the company has to produce at least 4 a week. For their production line, one of the most complex in the world, time is big money. Each Trent ever jet engines were developed by Sir Frank Whittle. And today, this small community still plays a very special part in the building of every Trent engine. Raw materials arrive at the factory every day. Solid sheets of high-grade titanium. They're destined to become one of the components that make Rolls-Royce Trent engines truly unique.
When you walk onto a plane, you look into the engine, that's the fan blade, and that's what we make here.
Mike Wallace's job is to transform the raw metal into high-performance fan blades.
The fan blade delivers 75% of the engine's thrust. It shifts about 1.2 tons of air per second, and the loading on the blade is something like 90 tons centrifugal load when it's at full throttle.
That's like hanging 13 double-decker buses off each of the 20 blades. The enormous fan is what distinguishes a modern jumbo engine from older turbojets. They didn't have a fan at the front and relied entirely on the jet exhaust to thrust the plane forwards. Faster than a propeller, but inefficient and very noisy. But in a turbofan, like a Trent engine, the energy of the exhaust is harvested to turn the massive fan blades at the front, which in turn push huge amounts of cold air quietly around the sides of the engine. And that's what thrusts the plane forwards. The Trent fan blades are unique.
So, which section is this?
And it's all down to their design.
The original blades used to be solid, but in order to get better performance, take weight out of the engine, it was designed to be hollow, and our manufacturing processes, which is unique, has actually enabled us to make that and advance the technology within Rolls-Royce.
Every single fan blade is worth as much as an average family car.